Hey guys, welcome back to the CAIE lab. Let's begin today's video by solving some important past paper questions from the topic we've already covered. After that, we'll continue with some important concepts that you need to know for your exams. So let's get started. So the question number 1 says that what is produced by the bacterial oxidation of ethanol? Now, during the process of oxidation, the alcohol reacts with the atomized oxygen to form carboxylic acid and water. And when ethanol is oxidized, the product is ethanoic acid and water. Now, according to the important exam tip that I told in my previous video, the food name for ethanoic acid is vinegar. Vinegar is ethanoic acid, and therefore our correct answer here is D. Now, we cannot consider the rest options correct because ethene is an alkene, and the sodium ethanoate is a salt, and the ethyl-ethanoate is an ester, and therefore these are not the products of oxidation of ethanol. Alright, so now let's move on to the second question. The second question says that ethene reacts with hydrogen in an addition reaction to form ethane. This process is also called hydrogenation, which is the industrial preparation of alkane. And ethane here is an alkane. So the catalyst used here is nickel. It cannot be iron, it cannot be vanadium fiber oxide, and it cannot be yeast. So the right answer here is B. Alright, so now let's move on to question number 3. The question number 3 says that ethane reacts with chlorine. Here, ethane is an alkane and chlorine is a halogen. And whenever there is a reaction between alkane and halogen, that is always the substitution reaction. And we cannot consider addition reaction correct here. Now, the second product of substitution reaction is always the hydrogen halide. Here, hydrogen chloride is an example of hydrogen halide, and therefore this is our correct answer. The second product of substitution reaction is not hydrogen. So the right answer here is C. Alright, so now let's move on to the question number 4. The question number 4 says that the structure of an ester is shown here. This is an ester, and now we have to name this ester. Now, let's see the first part, which comes from the acid side, and the second part, which comes from the alcohol side. Now, in the first part, we have 3 carbon atoms, and therefore the ester used here is propanoic acid. Now, let's see the alcohol side, and here we have only 1 carbon atom, and therefore the alcohol used here is methanol. Now, while writing the name of ester, the first part comes from the alcohol side, and we remove that old thing and replace that with "-ile". So the right answer here is methyl. And while writing the ester name, the second part comes from the acid side, and we remove that OH thing and replace that with O8. So the answer here is propanoate. Propanoate. So the name of ester here is methylpropanoate. Now let's see which option matches this answer. The first option says that it's ethyl methanoate. No, that is wrong. The second option says that it's methyl ethanoate. No, that is wrong again. The third option says that it's propyl methanoate. That's wrong again. And the fourth option says that it's methylpropanoate. Yes, that is true. So our right answer here is D. Alright, so now let's solve the question number 5. It says that the ethanol is produced by the fermentation of aqueous glucose or by the catalytic addition of steam to ethene. Which will show some advantages and disadvantages of these processes. Now the question is asking us about the 2 main methods of preparing alcohol and saying us to consider the correct advantages and disadvantages of these processes. Here we have 2 groups. The first one is of the fermentation process and the second one is of the addition reaction. So let's talk about the fermentation process first. The advantage says that it's a fast reaction. No, that is wrong. The fermentation process is a very slow process. The ethanol produced is in batches. Yes, that is true, but it cannot be considered as an advantage because it makes the process very slow. One batch needs to be completed before another starts. So this is wrong again. It uses renewable raw material. Yes, that is true. Now let's move on to the disadvantages. Ethanol is produced continuously. That is wrong. Ethanol is produced in batches. It is a slow reaction. Yes, that is true. Ethanol produces in batches. Yes, that is true. And it makes the process very slow, so it is a disadvantage. The ethanol formed is very dilute. Yes, that is true. The ethanol formed is very impure. It needs to be separated by fractional distillation before it can be used. Now let's talk about the addition reaction. The first advantage says that almost pure ethanol is formed. Yes, that is true. The catalytic addition is a fast reaction. Yes, that is true. Now, disadvantage says that it uses renewable raw material. That is wrong. It uses non-renewable raw material. Ethanol is produced continuously. Yes, the ethanol is produced continuously, but it makes the process fast, so it cannot be considered as a disadvantage. This is wrong. It is a slow reaction. This is wrong again because the addition reaction is a very fast reaction. Non-renewable raw material is used. Yes, that is true. So the right answer here is D. Now let's move on to the question number 6. The question number 6 says that which statement about aqueous ethanoic acid is correct? The option A says that it reacts with magnesium, which is a metal, to form oxygen gas. Now, whenever there's a reaction between the acid and a metal, the gas formed is always the hydrogen. So this is wrong again. Now let's talk about the option B. It reacts with sodium carbonate to form carbon dioxide gas. Sodium carbonate is a metal carbonate. And whenever there is a reaction between the metal carbonate and the acid, the gas produced is always the carbon dioxide. Option C says that it turns red litmus paper blue. That is wrong. The acid turns blue litmus paper red. It turns methyl orange yellow. This topic we're going to study in a later chapter, but for now remember that the acid makes the methyl orange red, not yellow. So the right answer here is B. Alright, so now let's move on to the question number 7. The question number 7 says that the propene undergoes addition reaction with bromine, hydrogen, and steam. Which structures represent a product of these reactions? Now we know that these reactions produce dibromoalkane, an alkane, and an alcohol, so one of these structures must represent each of these products. Let's look at structure 1 first. It looks like a dibromoalkane, but it is not correct, and let me show you why. Here we have the structure of propene, and you can notice that the double bond is between these two carbon atoms. During an addition reaction, when the double bond breaks, the one bromine atom attaches to each of these two carbon atoms, and therefore the product looks like this. Now compare it with the structure 1. You can notice that the one bromine atom is attached to the wrong carbon atom, and therefore we cannot consider it correct. Let's move on to the structure 2. The structure 2 has only one bromine atom, but the bromine reacts as Br2, so 2 bromine atoms must be added across the double bond, and therefore we cannot consider it correct too. Now look at structure 3. It represents an alkane, because whenever hydrogen is added to propene, the double bond becomes a single bond, forming an alkane. So the structure 3 is correct. Now let's move on to the structure 4. Structure 4 is also correct because this represents an alcohol, because it contains a hydroxyl functional group, making it an alcohol. Now this compound is called propan2O. I know that this name seems new to you, but don't worry. We'll study how to name the compounds when we're going to study isomerism later in this chapter. So the correct answer here is D, structure 3 and 4. Now, as another example, we have a structure of butene here. And you can see that the double bond is between these two carbon atoms. So when the double bond breaks, the Br bromine atoms come at this place, and they attach to two carbon atoms that were originally joined together by a double bond. And this is how this product is formed, so you must remember that whenever you do something related to the addition reaction. Now let's move on to the question number 8. The question number 8 says that which statement about the ethanoic acid is correct? Option 1 says that ethanol is reduced by bacteria to produce ethanoic acid. Here, this thing is wrong. Ethanol is oxidized, not reduced. And that is why that process is called oxidation of ethanol. So this is wrong. The second option says that the ethanoic acid reacts with magnesium to produce a salt of formula CH3COOMg. Let me show you how to form this compound. And later we're going to see that is the molecular formula of this compound correct or not. So we have two ions here. We have firstly the ethanoate ion, which looks like this and has a -1 charge. And then we have the ion of magnesium, which has a +2 charge. And now the charges are exchanged, and therefore it looks like this. It becomes CH3COO bracket 2Mg. And therefore the molecular formula of this compound is not correct, and therefore this is wrong too. Now the third option says that the ethanoic acid and methanol react in the presence of an acid catalyst to produce ethyl methanoate. Now, yes, sulfuric acid acts as a catalyst during the esterification, but the name is not correct. Let me show you how to name it. So the first part comes from the alcohol side, and the second part comes from the acid side. And we remove that old thing and write "-ile" instead of it, so it becomes methyl. And we remove that OH thing and replace that with OH, so it becomes ethanoate. And therefore, the correct answer is methyl ethanoate, not ethyl ethanoate. So we cannot consider this option correct. Now the last option says that ethanol reacts with acidified aqueous potassium manganate to produce ethanoic acid. Yes, that is true. This is the oxidation reaction where this acidified aqueous potassium manganate acts as an oxidizing agent. And therefore, this answer D is correct. Alright, so now let's talk about the functional group. A functional group is an atom or a group of atoms that give a compound its chemical properties. In simpler words, you can say that a functional group is a part of the molecule that decides how the compound is going to behave in the chemical reactions. Here we have a carbon-carbon double bond as a functional group of alkenes, and whenever you see this carbon-carbon double bond in a compound, then that compound always belongs to the homologous series of alkenes. Then we have this hydroxyl group of OH as a functional group of alcohols, which gives the alcohols their characteristic chemical properties. Lastly, we have carboxyl group as COOH as the functional group of carboxylic acid, and it is responsible for the acidic properties of carboxylic acid. Now let's move on to the homologous series. A homologous series is a family of organic compounds that have the same functional group. And because they have the same functional group, they have similar chemical properties. Now, it is a group of compounds having the same general formula. This means that the same general formula can be used to represent every member of the homologous series. And secondly, there is a gradual change in the physical properties. Now, when the carbon chain becomes longer, the physical properties such as melting point and boiling point gradually increase. And thirdly, same method of preparation is used to prepare each member of the homologous series. For example, the same method of the hydration of alkenes is used to prepare alcohols. The same method of the hydrogenation of alkenes is used to prepare alkanes. And the same method of oxidation of alcohols is used to prepare carboxylic acids. Now, the last thing is that each member should differ from the next member by a CH3 group. It means that the successive members differ from the previous one by one CH3 group. And it can be better explained by this example. The alkanes, which are represented here with their molecular formulas, and you can see that each successive member differs from the previous one by a single CH2 unit. And the same pattern can be seen in the alcohols. And this is the easiest way to identify the homologous series in your exams. So this is all for today. I hope you liked my video and understood the concept. Don't forget to hit the bell icon and subscribe to my channel. Let's meet in another video.